After we get this recurrence relation, we want to solve this problem by using generating function. Then first we need to design the corresponding generating function. Here we want to solve Hn. Thus, we may design corresponding general terms for different n, so that we can get this generating function, which is gx. The coefficient of gx corresponding x to the power of k is hk. So it is written as gx equal to h1x plus h2x squared plus x3 x cubed, continue to accumulate. Next, we show you that how to solve corresponding recurrence relation by using generating function. We already have the corresponding recurrence relation of Tower of Hanoi. Then we hope we can solve the general term expression of recurrence relation through generating function. This time we know corresponding to the exponential level expressing power series. It can also do for operations. Thus, generating function is just like normal algebraic expression, can do addition, subtraction, and so on. We write down the corresponding generating function of Hanoi Tower here. If we want to do certain for operations to it and try to make good use of this kind of recurrence relation, we will find that this term is half of this term on the right side. Well, the corresponding power of this side is x to n's power, and the corresponding power of this side is x to n minus 1's power. Thus, we can design another term called 2x times hx. In this way, through addition and division between two generating functions, we can eliminate some of the elements by using recurrence relation. For example, we can see the left side formula, which will be hx minus 2x hx. Well, if according to the exponential one-to-one correspondence, we will find that coefficients of each term on the right side are just the corresponding recurrence relation, such as the first term on the right side, h1x is 1x. Well, for the h2x squared minus 2h1x squared, the coefficient is h2 minus 2h1. Since h2 equal to 2h1 plus 1 according to the recurrence relation, so the coefficient here is 1. Same as h3 minus 2 times of h2 should equal to 1. We will find out the recurrence formula helps us to simplify here. Therefore, we can further organize right side terms, which converted into x plus x squared plus x to the third power. Because we know 1 over 1 minus x actually equals to 1 plus x squared. We pick x from this formula, and then it changes into x divided by 1 minus x. After sorting out the two sides, hx equal to x divided by 1 minus 2x times 1 minus x. Maybe you guys will say, I can't figure out directly minus 2 times of x hx. Is there any more intuitive method? In fact, we can also directly using the definition of generating function to find out recurrence relation, such as we use another method. Here we know that for each x to the fifth power, there is always hx which corresponds to it. Then for such a formula, it can have certain recurrence relation as well. We list every term here. Then we will see the coefficient of x squared is h2. Well, corresponding to recurrence relationship, h2 equals to 2 times of h1 plus 1. The corresponding coefficient of x to the third power is h3. It is equals to 2 times of h2 plus 1. If we let x squared multiply by the opposite left and right side, x to the third power also multiply by the two terms on left and the right sides, then oddly summed up, what will be the result? Sum up the left side of the above equations actually is a part of a corresponding generating function. Who missed? The coefficient of x is missed. Therefore, on the left, h2x squared plus h3x to the third power continue to accumulate, which equals to capital hx minus h1x. h1 is equal to 1, thus hx minus x is the left term. What about the right side? It will be divided into two terms. 2 times h1 here need to be multiplied by x squared. Well, 2 times of h2 need to be multiplied by x to the third power. That's in the first column. For the first term from right side, we can say h1 itself corresponds to the coefficient of x. Then what is the difference comparing with the side multiplied by x squared? 1 more x. And there is one more coefficient 2 before it. Correspond to this term, corresponding to h2 should be x squared, but I multiply x to the third power here. Thus, if it has one more 2 times of x than the original generating function, then we will find that actually the first term on right side, 2 times of h1 x squared plus 2 h2 x to the third power has been accumulated, which equal to pick 2x from each term, and the rest is h1x plus h2x squared continually accumulated. This term is just what we are talking about, generating function. Thus, the first term on right side can be directly written as 2 times of x multiplied by hx. And what about the second term on the right? Here it becomes x squared, x to the third power, x to the fourth power continually multiplied in term. So the second term on the right equal to x squared plus x third continually accumulated, which equal to pick x squared out, the rest is 1 over 1 minus x. Then after reorganizing these three terms, we can see hx minus x equals to 2 times of x multiplied by hx plus x squared divided by 1 minus x. Reorganized, then we also obtain exactly the same fraction expression as the one we get through above method. This is a fraction expression of corresponding Hanno-Tauer generating function, but it doesn't end yet. We also need to solve that how to obtain the coefficient of each x to the kth power, which is a corresponding counting sequence. Next, let's think about it. The generating function should be expressed as hk multiplied by x to the kth power. We're going to solve hk. Now, we already know the generating function equal to x divided by 1 minus x multiplied by 1 minus 2x. Then what shall we do next? We hope we can turn this formula into some fractional expression, which we well know. How can we obtain the corresponding sequence from a generating function? We need to use a method that can convert such a fraction into partial fraction. For example, assume hx, because its denominator is 1 minus x multiplied by 1 minus 2x, then it can be written as a divided by 1 minus x plus b divided by 1 minus 2x. A and b are undetermined coefficients. We hope we can get further solutions for that. After we merging the denominators here, the new numerator becomes a multiplied 1 minus 2x plus b multiplied by 1 minus x. The denominator becomes 1 minus x, 1 minus 2x. The numerator is a plus b as a constant term. The coefficients of x is 2a plus b. Then this denominator should be 1 to 1 corresponding to the original denominator. Thus, we know the simultaneous a plus b minus 2 times of a plus b x should be equal to x. It seems a constant term a plus b should be 0, and the corresponding coefficient of x is negative 2a minus b. It should be 1. Then two constant undetermined coefficients can be completely solved through this equation set. Obtain a is negative 1, b is 1. Then we can know capital Hx equal to 1 divided by 1 minus 2x minus 1 minus x. Then we can see that this equation can be expanded as 1 plus 2x plus 2 square x square plus 2 to the third power x to the third power, and it can be written as 1 plus x squared continuously accumulated. So their coefficients reorganized together is a 2 to the kth power minus 1. Well, the coefficients of x to the kth power is just the complexity of Hanno-Tauer, which we want to solve. This is to say hk actually equal to 2 to the kth power minus 1. This moment, we want to know, going to move 64 disks. In fact, it's H64. The answer is 2 to the 64th power minus 1, got such a big value. After calculation, we find that for 64 disks, finally move from A to C, whose complexity is so high enough that we cannot count. But if we assume that we can move a disk in a second, then how long it will take till the world ends? We calculated, in fact, it cost around 580 billion years to place 64 disks from pillar A to C. So I think you guys will do not worry about it now.